Yeah, hello everyone. Okay, so in today's video we're talking about similar triangles. So in my last video we were talking about congruent triangles. And if congruency means the same triangle, similar triangle means same-ish. Same-ish. So usually when we say two triangles are similar, so similar triangle, these triangles all share the same angles, right? But they appear to be different sizes. Well, appear, they are, right? So, for example, I have a triangle here. I have to say this angle is 50, this one 60, therefore this one is 70, right? 50, 60, 70. I can have a much bigger triangle with the exact same angles, right? So this is called similar triangles because it's the same triangle shape-wise, but one is just bigger than the other. So that leads us in to theorem 13. So the theorem of similar triangles. So if two triangles are similar, then their sides are proportional in order. That means the sides are proportional to each other. So what does that mean, right? So say for example here, this side is 5, this is 10. These two sides correspond to each other because they both lie between side A and B. How do I get from 5 to A? I multiplied it by 2. So say this side is 3. How can I find out what this side is? Well, I just scaled up this triangle times 2, didn't I? So 5 times 2 is 10. Therefore, 3 times 2 is going to be 6. So that's going to be 6. So how do we do that? How do we do questions like this? So usually what we say is all the sides are proportional to each other. So PQ, so this side divided by this side, so PQ divided by DE, well, that's going to be equal to this side divided by this side, which is also equal to this side divided by this side, right? Then conversely, if the sides in any two triangles are proportional to each other, we can say that they are similar. Note as well, so this is another theorem. If a triangle is cut by a line parallel to one of its sides, right, then two triangles formed are similar. So if here, for example, we have the bigger triangle here, and I've cut it with a parallel line, I've now made two similar triangles, right? So my first triangle is this little one here, and then my bigger one is going to be this one. So I made two similar triangles because they all share the same angle. So let's do a few questions, right? Probably sick of hearing me talk. So let me let this load. God. Right. Right. So triangle ABC is similar to triangle ADE. So AB is equal to 8, BC is equal to 6, and BD is equal to 4 centimeters. Work out the length of DE. So I have two triangles here. First, let's draw these out, right? So I have triangle ABC. So let's sketch out our question. So A, B, C, and we have a bigger triangle A, D, E. So we know these are similar to each other. Gorge. Therefore, we know the sides are proportional to each other. So A, D, E. So A to D, the entire side is going to be 12. Because if this section is 8, therefore and this section is 4, the total thing is going to be 12. We are looking for DE, so I'll call that X. Then my little triangle here, we know this is 8 and this is 6. So work out the length of DE. So we're going to be using my laws or my theorem of similar triangles. So the sides are proportional to each other. So I know, right, AD divided by AB. So this side divided by this side should be equal to this side divided by 6. So it should be equal to DE divided by BC. Now you might be asking yourself, is there any reason why I did AD divided by AB? Could I not do AB divided by AD and then vice versa? Yes, right? You can do AB, so AB divided by AD and BC is equal to BC divided by DE. You can do that. I, however, started with AD on top because therefore that gives me my X on the numerator, which is much easier to work with. So AD divided by AB. So AD is 12, AB is 8. That should be equal to x divided by 6. So I have x divided by number. I want to get rid of it. So I'm going to multiply both sides by 6. So 6 times 12 over 8 should be equal to x. Therefore, x, or in this case DE, should be equal to 9. Right? So DE is equal to 9. And I have just used my laws of similar triangles to do that out. So I'll do a few more examples. Let's have a look at this example here. So this is from the 2014 paper. So in the triangle below, it gives us here angle MNP is equal to angle P or Q. Okay, so let's draw that in. So MNP, so MNP. So this angle is equal to P or Q, P or Q, this angle here. Prove that triangle MNP and Q or P are similar. So I need to prove that these two triangles are similar. So this triangle is similar to this triangle. So I need to prove that. So let's have a look. I need to prove that all the angles are equal. Well, I know for a fact, right? This angle here is going to be equal to that angle here because opposite angles are equal to each other, right? And if they share two angles here, right? If they share two the same angles, therefore the third angle has to be the same one. Because if this was like 50 and this was 60, well, the other triangle has to be 70. The other angle has to be 70, right? Same as this one would have to be 70 as well. So if at least two of them are the same, the third one has to be the same as well. So therefore, we know that these two angles are equal to each other. So prove that they are similar. So you're going to do your little theorem statements like we do for congruent triangles. Yeah. So I know angle MNP is equal to P or Q. That is given. I know as well angle MPN is equal to angle QP or goes opposite. Right, and then therefore, which implies that angle PMN equals angle PQ or. Right, so it implies that. Therefore, prove not dissimilar. Is NM parallel to QR? So this is part 2. Give a reason for your answer. So is this line parallel to this line? Well, yes, right? They are, because if we look at here, this angle is alternate to that angle, right? So these are both alternate angles, so therefore they are, these lines have to be parallel to each other. Right. So find the last one. Find the length of QR. So QR, we're looking for this length here. So I know this angle is equal to this angle. I know this angle is equal to that angle. And then I know this angle is equal to that angle. So we need to make sure we find a similar triangle's corresponding side, right? So I'm going to draw out angle P, my triangle PQR. There it is. This is X, this is 10, this is 9. This is going to be my purple angle. This is going to be my blue angle. And this is my dot. Now let's look at the other triangle on top here, right? NMP. So this one here is my purple one, this is my blue one, and then this is going to be my dot here. This is 6, this is 4. So I need to find the ratio QR. So I put QR on top of my fraction. What side does that correspond with? Right? So a load of yous might automatically think it's something else. It's going to be 6, right? Because 6 here on the other triangle lies between the blue and the purple angle. So QR over 6 is going to be equal to, what side is corresponding with the blue and the dot, with this 4? Well, that's corresponding with the 10. So I know Q over R, so x over 6 is going to be equal to 10 over 4. Let's multiply both sides by 6. I'm going to have QR is equal to 10 over 4 multiplied by 6, which is going to be 15. So QR is going to be equal to 15 centimeters. So I figured out the length of QR. Well, it doesn't say centimeters, so it'd be 15 units. Find the length of QM. So QM, now we're looking for that QM. That's going to be this entire side. Well, I know this is 9. So obviously I'm looking for this little bit in the corner here. So let's go back to my little diagram here. So now I'm looking for this side. I'm going to label it Y. So PM, what side does that correspond to? So what's the side between the purple angle and the dot? Well, that's 9. So PM over 9 should be equal to 4 over 10, right? So if I'm starting with this triangle, all my numerators come from this triangle. Multiply both sides by 9, so 4 over 10 multiplied by 9. So PM is equal to 3.6. So therefore, QM is equal Q to P plus P to M. So Q to M is equal to 9 plus 3.6. Q to M is equal to 12.6 units. And that is an example of where you have to make sure you're matching up and finding corresponding sides with a similar triangle. So let's look at one more example. Let's look at one more exam question. So again, this also as well comes from the 2014 exam paper. So 3 paths A, B, A, E, B, E, and C, D have been constructed to provide access to a lake from the road AC as shown in the diagram. The lengths of the path of the road are as follows: 120, 80, 200. Explain how those measurements could be used to find ED. Because triangle AEB is going to be similar to ADC. So I'm going to be using similar triangles for this one, right? So let's label the points AE, that's 120, BE is 80, CD is equal to 200. Find ED, so we need to find the length of the river here. So again, let's sketch this out. So ADC. I know this is 200. I don't know the length of AD, so I'm just going to call all of that. Let's going to call it AD for now. Then let's look at my smaller triangle here, this one. So I have a smaller triangle here, EDA. This is going to be 80 and this is 120. So let's use my similar triangles now, because if I know what my entire length A to the ED is, I can then just subtract 120 and can find the length of ED here. So I know for a fact AD divided by 120 is going to be equal to 200 divided by 80. So this side divided by that side. Again, multiply both sides by 120. AD is equal to 200 divided by 80 multiplied by 120. I'm going to get AD is equal to 300 meters. But that's not what's asking me in the question. The question is asking me find ED. So ED is here. So if the entire thing is 300 meters and the first bit is 120, therefore this bit has to be 180. So ED is equal to 180 meters. So the length of the river is 180. And so there you go, that's similar triangles. I hope this was some help to you guys. and I'll catch you later. Bye.